A copper block of mass 2.5 kg is heated in a furnace to 500 degrees Celsius and then placed on a large ice block. What is the maximum amount of ice that can melt? Given specific heat capacity of copper, that says copper is equal to 0.39 into 10 raised to 3 joule kilogram raised to minus 1 Kelvin raised to minus 1. Latent heat of fusion of ice 335 into 10 raised to 3 joule kilogram raised to minus 1. You have to find the amount of ice that can melt. So we have the mass of copper, M copper equal to 2.5 kilogram. The change of temperature of copper block is from 500 degrees Celsius to 0 degrees Celsius. That is 500 minus 0 equal to 500 degrees Celsius. On converting to Kelvin scale, the value of change of temperature remains the same. So delta T is equal to 500 Kelvin. Also we have specific heat capacity of copper 0.39 into 10 raised to 3 joule kilogram raised to minus 1 Kelvin raised to minus 1. By principle of calorimetry, heat lost by copper block is equal to heat used by ice to melt. Heat lost is given by the equation ms delta T. Here M is M copper, S copper and delta T. Heat used by ice to melt is equal to M ice into latent heat of fusion of ice. So M ice is equal to MCu SCu delta T by LF. And substituting the values MCu 2.5, SCu 0.39 into 10 raised to 3, delta T 500. Also LF is equal to 335 into 10 raised to 3. On substituting the values and calculating, we get the mass of ice that melts as 1.46 kilogram. In an experiment on specific heat capacity of a metal, a 0.2 kilogram block of the metal at 150 degrees Celsius is dropped in a copper calorimeter of water equivalent 0.025 kilogram containing 150 centimeter cube of water at 27 degrees Celsius. After dropping the metal inside the calorimeter, the final temperature of the metal, copper calorimeter and water will be 40 degrees Celsius. Compute the specific capacity of the metal. So we have mass of solid ms 0.2 kilogram. Mass of water can be found by the equation mass is equal to volume into density. Volume is given as 150 centimeter cube. On converting centimeter cube to meter cube, we get 150 into 10 raised to minus 6. Density of water is 1000. So mass is equal to volume into density. On multiplying, we get 150 into 10 raised to minus 3 kilogram. Next, heat lost by solid. We are going to use the equation ms delta T. So ms SS into delta T. Mass of solid ms is equal to 0.2 kilogram. SS is written here. Change of temperature of solid is from 150 degrees Celsius to 40 degrees Celsius. That is 150 minus 40. In Kelvin scale also we get the same value. On multiplying, we get 22 into SS. Mass heat gained by water equal to mass of water 150 into 10 raised to minus 3. Specific heat of water 4128 into change of temperature, that is 40 minus 27. Initial temperature is 27 and final temperature is 40. So 40 minus 27. On multiplying we get 8049 joule. Heat gained by calorimeter. We are going to use the mass as 0.25 kilogram. Water equivalent of copper calorimeter means the amount of water that holds the same amount of heat as the copper calorimeter if we replace the copper calorimeter with water. So we can use the mass of water, that is what mass of water equivalent instead of mass of copper, that is 0.025. The specific capacity of water 4128 and change of temperature is 40 minus 27. So we get 1342. By principle of calorimetry, heat lost by solid is equal to heat gained by water plus heat gained by copper calorimeter. We can now substitute the values. Heat lost by solid 22 into SS. Heat gained by water 8049 joule. And heat gained by copper calorimeter 1342. On solving, we get the specific heat capacity of the metal as 427 joule kilogram raised to minus 1 Kelvin raised to minus 1.